Let's take a look at the completing the square method for solving a quadratic equation. To begin with, the equation that we are trying to solve, x squared plus 6x minus 15 is equal to 0. That equation is not going to be easily factored. And if we can't factor it, then we need to find another method that can help us to solve our quadratic, to solve our problem. So in order to do that, we're going to use the completing the square method, and we're going to modify our equation so that part of the left side of the equation is going to be a perfect square quadratic and something that's easily factored. Okay, so in the form that it is at the moment, we're going to have to do a little bit of work until we can actually factor and solve our problem. Okay. So let's go through some of the steps of the process of completing the square. To start the method here, we want to move the original constant, that negative 15, to the other side of the equation. Okay, to make some room for our new constant that's going to complete the square. Okay, so to start with, we're going to add 15 to both sides. Okay, and when you do that, we're going to have a new equation that looks a little bit like x squared plus 6x plus a new constant, okay, some term that I'm going to leave space for, is equal to, and we've got 15 on the right side of the equation. Okay, so I left some space here, and that's something that I want you to do. You want to leave room for the new constant that you're going to be adding in. Okay, and if just like the golden rule of algebra states, if we do an operation to the left side of the equation, we got to do the same operation to the right. Okay. All right. So our second step is that we want to add our new constant to complete the square. Okay. And that constant is always found using the term in that step, okay? And that's b divided by 2 quantity squared. Okay, so first we need to figure out what that constant is, what we can add. Okay, so I'm going to do that kind of on the side here. Remember, our term should be b divided by 2 quantity squared. Okay. And it again means that we've got to identify what our b coefficient is. Okay, so in our quadratic, our b coefficient here is going to be positive 6. And we're going to substitute that in for b. Okay, so we'll have 6 divided by 2 quantity squared as our new constant term. Okay, so 6 divided by 2, that's 3. 3 squared will give us 9. Okay, so 9 is going to be the constant that completes the square. And so that's what we're going to do for step 2. We're going to add 9 to both sides of our equation. And we've now completed the square by making the left side of the equation a perfect square quadratic. Okay. All right. The nice thing about that is once you've made a perfect square, it is very easily factored. And there's a way that you could do that. You can factor it using whatever method you choose. But if you notice, okay, if we factor it, we're going to have x times x, okay, which gives us our x squared term. And our constant terms, okay, we have to find 2 factors that multiply together to give you a positive 9, but add to give you a positive 6, okay? And there's one factor pair that does that, and it's easy to see that we're going to have both positive 3 as constants, okay? 3 times 3 will give us 9, and 3 times 3 adds to our linear term as well. It adds to a positive 6. Okay, so we've got x plus 3 times x plus 3 as our factorization. okay? And I'm going to write that a little differently, okay? So I'm going to write it because those two binomials are the same, okay? X plus 3 times x plus 3. We can write that as just being x plus 3 quantity squared, okay? So we're just going to write it as a perfect square, like x plus 3 quantity squared. On the right side of our equation now, 15 plus 9 will give us 24. Okay, and we've really taken a difficult problem and made it a pretty simplistic looking problem that's factored so far. Okay, so again, now we're trying to solve the problem. We're trying to find a solution to it, and to do that, we have to solve this particular equation. Okay, x plus 3 quantity squared is equal to 24. We first want to eliminate, okay, we want to eliminate that squared, that exponent, okay? And to do that, you can do the inverse of squaring something, which is taking the square root, okay? So we can get rid of that exponent, the squared term, just by taking the square root, okay? So if we took the square root of the left side, we need to take the square root of the right side of the equation as well. That's our golden rule. Okay. When you do that, remember, since it's an inverse, it simply just eliminates your squared term on the left. It eliminates your exponent. Okay. And you're left with x plus 3, and that's equal to our square root of 24. Okay, so now it's a simple problem to solve from here. We want to isolate x, so we're going to subtract 3 from both sides of the equation. Okay, and we'll have x is equal to, if we take the square root of 24, there are two possible solutions for that. There's a positive solution and a negative solution. Okay, so remember we subtracted 3. And then we can add the square root of 24 or subtract the square root of 24, okay? And this ends up giving you two solutions. So let's write the exact solutions, okay? So one would be negative 3 plus your square root of 24. We can simplify the square root of 24, and for right now, I'll just tell you that that is 2 times the square root of 6. Okay. Our other solution here, we would have negative 3 minus 2 times the square root of 6. Okay, so that 2 times the square root of 6, that's the same thing as our our square root of 24. Okay, so if you're wondering where that term comes from the square root of 4 times the square root of 6, which is the same as the square root of 24. Okay, and the square root of 4 we know is 2. Okay, so we've got 2 square root of 6, and we know that those are equivalent. Okay, so here we found exact solutions to our quadratic equation, and that's how you use that completing the square method.